Hello. In this video, we want to verify that 1 minus secant x cosecant x tangent x equals negative tangent squared of x is an identity. So to do this, we want to go ahead and start out with one side of the equation. And to me, the left-hand side looks more difficult than the right-hand side. So let's go ahead and begin with the left-hand side. We have 1 minus secant x cosecant x tangent x. And I want to make it look like negative tangent squared of x. We always want to keep the idea in our head of what we're trying to make this look like. Now, just for reference, negative tangent squared of x might be sine squared of x over cosine squared of x or something like that. So just keep that in mind. Now, notice that we've got a bunch of things happening over here. So instead of secant, I'm going to use 1 over cosine. Instead of cosecant, I'm going to use 1 over sine, and instead of tangent, I'm going to use sine over cosine. So notice that we're often going to just change everything back into everything in terms of sines and cosines. So we get 1 minus 1 over cosine of x times 1 over sine of x times tangent, which is sine of x divided by cosine of x. Now notice the sine of x's will cancel each other because one's on one side of the fraction, one's on the other. So one's the numerator, one's the denominator. The cosines do not cancel because they're both in the denominator, and we're multiplying. So this is going to give me 1 minus 1 over cosine squared of x. But again, we don't really generally like to keep stuff in reciprocal form like that, so we're going to move that to the numerator using its reciprocal. So it's going to give us 1 minus, and then the reciprocal of cosine is secant. So it's going to give us secant squared of x. Now remember from the previous video that we saw that tangent squared of x plus 1 is equal to secant squared of x. Now notice that we've got 1 and secant squared of x. We've got 1 and secant squared of x. And I want to get a tangent squared of x out of that. Notice that there is a tangent squared of x. So notice what I can do is I can move this 1 to the right-hand side. If I do that, that means that tangent squared of x is equal to secant squared of x minus 1. So what I can do here is I can factor out a negative from both of these, and that's going to give me a negative 1 plus secant squared of x, which is the same as this, but a lot of people don't like seeing that, so what you can do is just flip those two around. A plus b is the same thing as b plus a, right? So this would give us negative secant squared of x minus 1. And notice that secant squared of x minus 1 is tangent squared of x. So just replace the secant squared of x minus 1 with it. And that's going to give us negative tangent squared of x. So there you go. That is the right-hand side. We started out with the left, manipulated it to get the right-hand side. Now, let me talk about what would have happened if you had chosen the right-hand side instead of the left-hand side. You would have started here, and to get up here, you would have to manipulate this. And you probably would not have thought about replacing tangent squared of x with secant squared of x minus 1. That would actually be the key here. And then once you do that, you can distribute the negative effectively, making that 1 minus secant squared of x. Then replace secant squared of x with 1 over cosine squared of x. And then break that up into two separate 1 over cosines, and then just put a sine and sine on different sides, and there you go. That's a lot more difficult, and so you have to be a little bit careful with this. Alrighty. Well, I'm going to go ahead and end the video here, and I will see you in the next one. Have fun.